All right. Hello, everyone. As was mentioned, my name is Robert Wood. I'm based out in the Washington, D.C. area, and I am super, super excited to be here in Paris. It's my first time at Hack in Paris 2018. So my goal for today is basically to give you all some insight into 10 different areas that have given me a lot of headaches throughout my security career, throughout the many steps in a supply chain. And so in all of those different areas, I want to cover, or I want to provide you with some practical takeaway, plug and play tactics that you can use to manage risk in your own supply chain. And so before we jump right in, I'll do a quick little rundown on myself. I've been working in security for about 10 years now. I'm living in the U.S. I started my career in consulting. I then went on to run the security program for a healthcare company called Nuna Health, and then moved on to SourceClear, where I was the chief security officer just prior to their acquisition at CA Technologies Veracode. So jumping right in. Quick disclaimer. So these slides have a lot of material in them. I'm not going to be super, super thorough in the interest of time, but everything is already posted online at my website, and I have tweets going out and all of that with links to the slides. So if anyone wants those, please feel free to grab them and consume the material, whatever you want or need to do, whatever you're going to get the most value out of. So, supply chain. Everyone here coming from the security and engineering field is likely familiar with an SDLC or a DevOps lifecycle. And from a customer's perspective, they really only see what's on the other end of the spectrum, where they get to consume a product. We in the technology sector know that there's a lot of different steps that go into producing that product. Thinking through it from a DevOps perspective, we have this very, very iterative cycle where we're gathering requirements, we're developing code, we're writing tests, we're building artifacts, we're releasing those into production, and then we iterate through that entire process again. And of course, there's many other loops that can exist from code back to idea, design back to idea, depending on what kind of feedback that you're getting. And so this is just setting the stage for us all. And a supply chain, the definition that we're going to work with today, is the set of processes, tools, techniques, people, activities that go into producing typically a product or some kind of solution for a customer. And what I want to encourage everyone to do today is to think instead about producing a product, but rather about producing value for a set of stakeholders. And we'll get into why, I'll jump right in now. So the reason that value is important as opposed to considering just the product is that value is ultimately what the customer wants. The customer cares about having their problem solved, their needs addressed, and they don't necessarily care about one product over another. If I want to get online and, let's say, book a flight, I may not necessarily care about using one travel site over another or flying one airline over another. As long as I can get from point A to point B and do so safely and cost effectively, that's what I care about as a consumer. And so as a security team, thinking about value gets us closer to our organization's mission. So if we think about Twitter for a second, their mission statement is to give everyone the power to create and share ideas and information instantly without barriers. And thinking about security on the Twitter, within the Twitter organization, anything that impedes the ability for customers to create and share ideas and information instantly without barriers is something of a risk. And if we are more closely aligned with the organization with the organization's mission, we're ultimately going to elevate ourselves not from the point of, or elevate ourselves from blockers and gates and all of that within the organization, more as strategic advisors, partners within the business, which is going to put you in a much better position to get things done, at least in my experience. And so the way that we're going to have this talk organized is, of the 10 tactics, 5 will be focused within the DevOps lifecycle, 5 will be focused outside of the DevOps lifecycle, and things that we're typically not talking about as a security team, but ultimately, if you're working within a broader organization's program, will probably cause you headaches somewhere along the way. At least they have for me quite frequently. So, jumping right in, within the DevOps lifecycle, we'll start there. Technique number 1 is software composition analysis. So, quick show of hands, who here within their organization or as they've written software before is using any kind of open source libraries in the code that they're writing? All right, so most of the hands went up in the room. And so this might be anything that you see hosted on GitHub or GitLab. It might be including projects in a Django system. You might have something outlined in a pom.xml file, requirements.txt file, whatever it happens to be. There's a lot of different open source libraries out there. And just to give you a sense of how much code goes into a system when you start including open source libraries, this graph right here is a representation of a very simple application intrusion detection program. The first ring, or the ring on the innermost circle, is all of the direct dependencies that were included in this particular project. And then all of the concentric rings surrounding that are all of the dependencies that those immediate dependencies included. And I won't challenge anyone to count them out here. I've done it. There's over 70 additional libraries that were included as sub-dependencies or transitive dependencies in this particular project. And as a security professional, that's a lot of unknown code going into your systems that your company is producing. So, software composition analysis tooling is a class of solutions that helps you get a handle on or get your arms around the open source libraries or all of the other third-party code that's going into the systems that you're producing. And there's 3 main dimensions that you could evaluate solutions on in this particular category. The first, or the big heavy hitter piece of functionality, and this is stuff that open source solutions like Dependency Checker from OWASP provide, is checking the immediate dependencies that you're including. So those things that you're outlining in requirements.txt or whatever, for publicly known CVEs. The second is checking those immediate dependencies and the things that they're including, those transitive dependencies, for known CVEs and potentially for proprietary vulnerabilities. And then the third is checking whether or not you're actually calling the code that is vulnerable. So just because you're including a bunch of code doesn't necessarily mean that that code is vulnerable. It might just be lying there dormant. You might not be calling those particular API calls, whatever it happens to be. And if you think about this, if you were to graph this out, the more insight that you're getting in this particular class of tools, ultimately the more value that you're getting. So unlike things like static analysis, there's not a lot of extra work that has to go into tuning or maintaining this type of tool. It's just it's more of a core feature piece of functionality. So that was tactic number 1. Tactic number 2 is code analysis. So as your engineers, they've included their initial libraries and they start actually writing custom code. So I'm going to cover 3 main pieces of code analysis, or 3 main techniques. The first, linting. So linting, you could relate it to like your basic unit test, end-to-end test that engineers are writing. It's very, very, very customizable and very tied to your specific code base. Static analysis is much more heavyweight. It would run on an entire build. It oftentimes requires a lot of tuning, and there's a lot of false positives that come with it. It's a very heavyweight solution. It's like trying to pound a nail down with a sledgehammer. It will definitely get the job done, and if you have the time and energy and resources to tune it well, and apply it to all of the systems you need it applied to, then you can get a lot of insight with it. And then the third is binary analysis, which is something that, depending on the way that your particular CI/CD pipeline is set up, is going to happen completely out of band, which may or may not be a good thing depending on your particular organization. So, some considerations if you're looking to apply static analysis in your particular security program. Not everything, you don't necessarily have to do, and I would encourage you not to do everything, but rather to consider the time and resources that you have, any compliance or internal deadlines that you're working against, the technology stack that you're working with. So you don't necessarily want to procure a tool or download a tool that's very, very well suited to scanning Java when you are primarily a Python and Go shop. That tool, while it may be or those languages may be supported, it may not be purpose built for those sorts of languages or those frameworks that you're using, and you're probably going to spend more time wrestling with it and more time knocking your head against the wall trying to get it to work than you are getting useful insight out of it. And you also want to consider your deployment model. So if you're trying to move really, really quickly, then doing something out of band or doing something that's going to be big and heavyweight and slow your build times down, that may not be an ideal solution. So consider how your team is made up and what your goals are for how you want to write software, and pick your tactics appropriately, is my advice. Number 3 is threat modeling. So threat modeling is typically a design-focused activity that looks at the overall architecture of a software system or a set of software systems or services. And so it would typically produce a diagram like this. This is a really, really basic threat model that I pulled down off the internet, off of PureList, I think. And it's just of a basic e-commerce site. You have some web servers, you've got a firewall in there, you've got a load balancer, and you've got users connecting from their phones or just their computers. Now the problem with something like this, while you could, if you were to chart out your entire software's architecture, you're likely going to get a lot of insight into where things might be, where things could go wrong, and where you could make potential improvements. But the issue with generating this diagram is that it takes a lot of time. It's very labor intensive. And if you're trying to move very, very quickly in a DevOps oriented organization or development team, then by the time you end up with this artifact, this diagram, it's likely going to be out of date. You might have new components that have been introduced. You might have versions that have changed. You might have components that have been taken away. You might have security controls that have changed. And then the analysis that you're doing on that is going to take even more time. And then every bit of time that lapses is time that the system is changing, and this artifact is becoming out of date, which is an issue when it comes to threat modeling. And so one tactic that I found very, very effective in trying to achieve the same outcome, or at least an 80%, do 20% of the work for 80% of the outcome result of threat modeling in a DevOps-focused environment, is to focus on empowering the developers that you're working with, or the product managers, product teams that you're working with. And a really, really simple way that I've found to do this is to give them a set of questions that they can work with when they're flushing out stories, when they're figuring out what they want to build next. And this is a set that I've used with pretty good success. You can pick or choose any one of these. You can add, you can subtract, whatever's going to work best for you. But basically asking them or encouraging them to talk through the possible security implications of what is what change they're proposing or planning out, and how that might affect the overall system. So starting conversations like, what's the worst thing that could happen if we do this thing? Are we changing anything that's potentially sensitive? Are we accessing or changing the way that we're handling the sensitive things in our system? Maybe that's credit card data, maybe that's patient data, maybe that's it doesn't matter what the data is, because it's contextual to whatever it is you're building and your organization's working on. But by working with your developers, going through this process with them a couple of times, and then just encouraging them to have these sorts of conversations as they are flushing out stories, ultimately what I've found is that you'll end up with a more thoroughly written up story or feature or issue or ticket, whatever nomenclature you use in your organization or development teams. And if the ticket or the story is more well thought out and includes security requirements, then it will ultimately, it will more than likely be built to satisfy those requirements, as it is written to satisfy functional requirements. And so if that's the case, then you end up achieving the same outcome as threat modeling, or at least a good part of it. So number 4 is CI tooling. So the reason CI tooling is included in here is When I was consulting, I used to do a lot of penetration testing and red teaming. And for organizations that operate in this way, CI tooling is almost like the new Active Directory. If you want to find a really, really juicy target that has a lot of permissions that can get you just about anywhere you want to go in an organization, going after Jenkins or going after GitLab or whatever the CI build server is a really, really good target. And the reason that is that they have a ton of permissions to and from those servers. Because they're critical infrastructure in a lot of cases, they're typically not patched. They have a lot of credentials to be able to handle deployments, especially if if you have deployment tooling worked into it. And the ability, if you're able to compromise, because those systems are typically unpatched, a Jenkins worker or a GitLab runner, whatever it is, the likelihood that you're going to be able to pivot from that, or at least be able to sit and monitor and watch and wait from that position, is really, really good. And so as a security team, again, I'm going to focus on the 80-20 because I really truly believe that security teams have enough stuff to worry about that we can't focus on making every little thing perfect, or else you're going to A, drive yourself crazy, and B, never be successful, because those are really unreasonable expectations to try to live up to. So I found taking care of these three things is going to cover a lot of your low-hanging fruit. And then if you really feel the need to, you can circle back and look at additional hardening improvements or enhancements for your CI infrastructure. So the first thing is minimize who and what can make changes within the CI environment. So this is all about fine-grained permissions and just reining in what's actually happening on the CI, like the main Jenkins worker or the main Jenkins master. And then the second is to limit the permissions of the workers themselves. And in this case, you might want to pair workers up with particular projects that they're working on. And so you'd have project A worker building project A, project B worker building project B. And each of those workers has the projects, or has the credentials, has the access, all of that they need for the projects that they are building. Not all CI servers are capable of doing something like this. GitLab, for example, is. Jenkins, as far as I know, is not, which is one of my many beefs with Jenkins. And then lastly, make sure that you have a patching plan for it. So this is where you're going to work really heavily with your engineering teams to make sure that you have the ability to actually maintain the thing. Because oftentimes what happens is CI servers will get spun up, they'll get put in place, they'll start getting used, and then nobody really owns it, and it will go on and on and on. And before you know it, you're four major versions out of date, and nobody wants to touch it because you're 4 versions out of date, and everyone is relying on it. And if you stop the ability to make and produce builds in your company, then you're going to be in big, big trouble. And you don't want to be the team that stopped the ability to build software. As a security person, you're going to be in hot water with the rest of the company. And another thing that typically isn't talked about when it comes to CI infrastructure is actually checking what you're building, not the thing that is building it. And so in this case, because ransomware libraries and other malicious libraries are on the rise, we've seen a lot of work at Veracode and SourceClear. We've seen a lot of our customers end up including malicious libraries in the projects that they're building. So you have fat-fingered libraries that are it's basically typo squatting applied to the open source library scene. And these things are being used for ransomware, for cryptocurrency mining, things like that. And so analyzing what you're actually building, the build artifacts themselves, and ensuring that it lines up with what you are expecting to build is another useful step. And so this is an open source tool that you can use. It's like an open, it's basically like a CI sandbox that you can use for analyzing your build artifacts. It will check for open network connections, for CPU usage, things like that, and it comes with a sample project that you can run everything on. All right, so moving on. Number 5 is red teaming. So this is when we get to the end of the DevOps lifecycle and we start to have things that are actually working. We have things that are deployed. And so red teaming, the definition that I'm going to use, because this is a frequently debated topic. Red teaming is typically conflated or confused or used interchangeably with simple penetration testing. I'm going to focus on the definition that is an asynchronous or just adversarial analysis of your business or of a system. And from my experience and my perspective, or my opinion rather, the broader the scope, the broader the perspective that you're taking, oftentimes leads to the better and more resilient results. And so because red teaming is a big, heavyweight exercise, I think you can boil it down or apply it in a couple of different ways. The first is tabletop exercises. This is where you're getting a number of people from your company into a room and you talk through a hypothetical scenario and what you would all do if that hypothetical scenario were to occur. So it's almost like pre-incident response testing. And there's a really great Twitter handle called @badthingsdaily, I believe it is, and it's Slack friendly, all of that, and it'll basically produce an off-the-wall scenario like so-and-so's credentials were hacked, you got a weird phone call, or something showed up on your main website, and it's meant to encourage more informal, structured conversation around what you would do if this thing happened in your company. And by having those kinds of conversations, you're going to end up identifying a bunch of things that you may be doing and doing well, or may not be doing, and that you can go improve later. The second is, of course, full-blown, out-of-scope, or out-of-band, full-scope analysis. And so this is the big, expensive, time-consuming thing. And I would recommend doing it completely out of band so it does not affect or impede your DevOps lifecycle, because you do not want to slow down software development. And ultimately you want red teamers to be acting as true to form, true to their whatever adversary they are emulating as possible. So having them just completely operate out of band on their own free will, give them full scope. That's going to be, I think, the best way to go about that. And then the last thing, and this is related to just stirring up conversations, is enumerating your organization or your department's canonical risks. So those things, those most basic things or basic parts of things that are going to affect your ability to deliver value to your stakeholders. So that might be, if you're, let's say, a hedge fund, that might be information leaked about trades, malicious trades occurring or unauthorized trades occurring, intellectual property being leaked or stolen, things like that. And then you can start to use those canonical risks as an anchor point in the conversations that you're having across your company. And when it comes to actually stirring up or starting some kind of red team, I think there's a number of things that you would want to consider. You don't just want to dive right into it, because red teaming is a big, heavy activity, and it can be intimidating for people who are not used to dealing with the results. So first things first is you would want to make sure that any stakeholders that you're working with are primed, they're up to speed, they're actually bought into the process. I believe that the fuller the scope, the better. If you are picking the targets that the red team is to focus on, then you are inherently applying your bias to the situation. So you are saying, I believe this thing, this thing, this thing are going to be the best way that you, Mr. or Mrs. Attacker, is going to make your way into our organization. And don't touch that other stuff, because I'm pretty confident in that. Where oftentimes what I've found is that when security program managers or whoever is doing this picking, they're going to pick the things that they either feel confident in, or they're applying their own ideas, their own perspective to it. And the things that they never thought possible are really the things that attackers are probably going to find the most valuable. And then lastly is think through how you actually want to use and consume the results. Like, why would you want to do red teaming versus just some kind of basic scanning or penetration testing or something like that? Because red teaming really is, in my opinion, intended to focus more on the way that the business and the software systems within it interact. And so focusing on those interaction points is much broader and carries much more weight, because changing things that come out of a red team assessment is oftentimes going to it's going to be a lot harder. It's going to require a lot more momentum and stakeholders to be involved, things like that. And so really think through what your drivers are and how you want to use the results that come out of it. And do that before you jump into it, or else you might find yourself just kind of thrashing through a potentially difficult political situation. All right, how are we doing on time? Good. All right. So next one, we're going to jump into the ladder 5. This is focusing outside of the SDLC. So first things up is your marketing teams. So marketing is the folks who are splashing your logo all over the place, our sponsors here, handling your company's social media, your www.com websites. And marketing tools are really, really powerful oftentimes. They collect a lot of data. They work together in a lot of ways. They have a ton of integration points. And so, for example, if you were to get a GDPR request that said, I want to be forgotten, I want you to delete me from all of your systems, would you be comfortable working only with your company's engineering team to handle that request? I know I would not, because of the way that we do marketing and the way that our marketing funnels work and all of that. And so really think through what tools are being used, how they're being used, where they're being used. And some things that you can do about it is to start finding ways to, A, enumerate those tools and risk rank them. So whether you're collecting like an application or service inventory, try to find ways to integrate them into your corporate governance strategy. So IAM, log collection, things like that. You may also find it useful because the marketing tools are not going to change as frequently as the things that you're building in a DevOps-like fashion. Or through the DevOps lifecycle, is to build some kind of at least rudimentary threat model of what are all the things that you're using and how do they work together and where are they deployed. That way you have a picture that you can pass on or use to use within conversations with A, the marketing team, and B, internally with your security team. But the biggest thing, in my opinion, is to start a conversation with your marketing team and start learning about their goals and start trying to align yourself as a partner to help them do their jobs more effectively and safely. And number 2 is the sales team. So we all love sales in this field. I'm sure you've all had interactions with sales professionals. Sales teams are interesting because they're like the front lines of our organizations. They set the tone and they set expectations with the customers that our companies are trying to work with. And they, of course, have their own sets of tools. They have their own sets of data. They get some stuff from marketing. They may be collecting data about customer usage of a tool. There might be privacy concerns there. But I think the biggest thing is that last bullet point is what commitments are they making to the customers and how might those commitments land you in hot water. So if they're saying to a customer, because they're trying to make a sale or they may not fully understand something, how something works, and then it turns out that those things are not true or they want to go through an audit after the fact and check it, make sure that your sales teams are speaking truth about what is going on, how things work. And this involves you getting in front of them, working with them, giving them resources that they can use about how your security team works, all of that stuff. Sorry, I'm giving a thumbs up to the time, not just all of you. So security and contracting is another interesting thing. So legal language, that which ends up in contracts, is really, really important, it turns out, when things hit the fan, when things go really, really wrong. And the reason that it's important is it can be used to hold other parties in a legally binding contract accountable. And so you may find yourself on one of two sides or maybe both sides of a contracting process as a security professional. When you are, when it's your customers and they're asking you for security language of any sort, I would advise to try to do whatever you can to try to push for less strict commitments, such that they cannot be used against you. And so here's some example things that you might see pop up in language. Things like security audits and who's going to pay for them. Things like breach notification. I've seen breach notification language come across my desk that has been within 1 hour of any suspected breach, which is completely unreasonable if you really think through the mechanics of that. And then any penalties that may go into a contract if anything is not satisfied. And so if you do not want to be on the receiving end of something going wrong in a contract. So push for less strict or more vague commitments. And when you're the customer working with your vendors, you of course want to use the same techniques that your customers are using. So you want to get things in writing such that you can hold them accountable. So here are some examples that I've used, and I try to basically come up with some set boilerplate language that I provide to my legal team or external counsel, such that they can use this language, negotiate for it with any vendor that we're working with, and try to get as close to these terms and conditions as possible. And that also removes me from the need to constantly be involved in reviewing contracts, which is a huge time suck and time sink for me and my security teams. So next one is continuing on the vendor front. We have vendor risk assessments. So we all use a lot of different vendors to run our business, everything from the suppliers of our phones to suppliers of our laptops, to email, to logging solutions, to the CI servers that we talked about earlier. There's vendors that run just about everything within an organization, because it would be infeasible for us to build everything ourselves. And you want to be able to break down or categorize vendors based on what they're doing, what they're managing, how they're doing it, and how essential they are to your business. And the first thing that you need to do to actually go through that step is to track them all down. And so this is the authorized vendors that have gone through some kind of review or contracting process, and then the unauthorized vendors that people have just gone online, signed up for a credit card, and said, yes, I approve this application, and they start using it. So some things that I've found useful for tracking down all those vendors is first talking to people, or you can start using logs from like CASB tools, Cloud Access Security Broker tools, or firewall logs. You can also work with your finance team and basically follow the money and see what is being spent where, and then you can enumerate vendors that way. And then once you start to have all of those vendors, you can start to categorize them in whatever way is going to be most effective and efficient for you. And then once you have all of those vendors enumerated and categorized in some way, you want to be able to assess them in some way. So there's a lot of online resources. I'd encourage you not to reinvent the wheel, because there's a lot of great ones out there. You could do something really basic, like check if they have a third-party certification, like SOC 2 or ISO. You could also use online questionnaires from like the Vendor Security Alliance or Cloud Security Alliance. And then there's open source solutions like the Google VSAQ, which is like an online questionnaire. There's a zillion other commercial resources as well, but don't reinvent the wheel. It's not worth your time. Pull something down off the internet. All right, and then the last one, number 10, is incident response. So the reason I included this here is that within the DevOps lifecycle, us AppSec people really aren't too focused about how we're going to respond if something hits the fan. We just redeploy things, and we keep going, and we keep building faster, and we just keep pushing code and producing more stuff. But incident response, if something either does go wrong or is even suspected to have gone wrong, has the potential to really negatively impact your company's brand, your customers' confidence in you, your bottom line, and a number of other things. And so you want to really make sure that you have a firm plan, that you test it, that you try to improve it, and you commit to improving it over time. And then I think the most important thing in here is being sure that you include other stakeholders in that incident response process. So don't just make it a technical endeavor. Include legal, include your executives, include PR and marketing and sales and contracting. Include these other business functions, because incident response really is an organization-wide event that occurs. It's not just a technical problem, even though the means by which you may have been breached or things may have affected you might be a technical one. The ramifications or the consequences of it span much farther than that. And so, putting everything together, I want to leave two main thoughts and then focus on priorities, and then we'll wrap up with Q&A. The first is, as a security team, or any security team working within an organization, whether it's a government agency, a private sector company, we don't have the luxury of working on very narrowly scoped problems. And so, I would really encourage everyone to try to find ways to align yourself with something bigger than the narrowly scoped problem through which your job description may say you're working with. Even if you're just framing problems in a bigger, broader business context, that's going to start opening up doors for you to have more interesting conversations and more engaging, thought-provoking conversations with the people who can get things done, or people who can start greasing wheels for you, whatever that case is. But focus on what your company does to create value and what might impede that value. And that is going to elevate you to the status of business partner and not just gate, because gate is not a place you want to be. So priorities. I don't recommend that you take this away and just try to do everything all at once. Priorities is really about figuring out what to do, just the same as it is figuring out what not to do at any given time. And then when you have those things figured out, what to do, what you're not doing, for the next month, 3 months, whatever it is, stick to it. As best you can. You don't necessarily need to be all rigid and not focus on any kind of change, or not be able or willing to change if circumstances do. But don't just completely shift week to week to week and leave projects hanging or half done, things like that. And then figuring out what to do and what not to do really depends on your particular context, what's most important to you. It might be the things that are causing your team the most anxiety. It might be the things that are wasting the most time if you're constantly getting interrupted with vendor requests or contract requests, or maybe your engineers are constantly writing really wonky code, or whatever it happens to be. Figure out what things are most important and then focus on, or at least where you're going to get the most bang for your buck, the most impact, and then tackle those things first. And then I would also recommend, just as a general principle of getting things done, is to focus on one thing at a time and really get it done well, get it operational, get it working with other processes, get it working with other tools, whatever it is, before you move on to the next thing. So don't just try to check all of these different boxes. Pick a thing, really do it, nurture it, get it working, and then move on to the next thing. Because if you have half-done or half-baked processes or capabilities in place, the ongoing maintenance of those things might end up leading to more and more headache as time goes on, and you don't necessarily want that. And then last thing, I'd be remiss if I didn't mention it, that Veracode is hiring and building out its research team quite aggressively, which is all focused on AI, IoT, machine learning, sorts of basically next-gen cutting research. So if you want to just get in, break stuff, find out how it works, write papers about it, go talk about it, let me know, or just reach out or check out these descriptions. Links are again in the slides. But most importantly, I just wanted to again say thank you so much for having me here in Hack in Paris. I am super, super appreciative, and I will take any questions in the time that we have remaining. Awesome. All right. No questions? All right. Oh, all right. Mm-hmm.
So the threat modeling straw man presented threat modeling in a pretty bad light. Things like including individual software versions in it and whatnot. And I'm wondering if, just like DevOps kind of put the nail in the coffin of the heavyweight, Microsoft SDL process.
Right.
It doesn't mean we can't have a secure development lifecycle just because the old one is no longer relevant.
Sure.
I'm wondering if you think perhaps threat modeling, needs a refresh. We need people like 2018's version of Window and Frank and Adam to sort of reform the process and make it relevant again.
I think that would be amazing if we could do that. And I know there's some research happening trying to codify a threat model. I think there's an open source project called ThreatStack, or I'll think of the name of it and tweet it later, but where you basically have developers like writing in comments or certain descriptors within their code how a component works and how it interacts with one another, and then it basically analyzes everything and tries to assemble some kind of threat model or analyze the design and give you recommendations on that. There's also some work being done in at like the IDE level to try to focus on and identify design patterns based on the kinds of code you're writing, the kinds of APIs you're calling, the libraries you're including, things like that. But I don't think any of those things are quite there yet. And at least based on all of the threat modeling like groups that I'm a part of and the discussions I've had, I don't know anyone who is super confident about being able to do that at scale and really at scale and at DevOps speed, such that you'd be confident in the fact that you're up to date. So I think it boils down to either accepting the fact that you're going to be a little bit behind and still getting some value out of that, because it's not. I don't think it's completely pointless, but you do have to understand that you will be a little bit behind the development curve, or trying to find a lighter weight version of that and basically like off-shift or offload or shift the responsibility of having those design-oriented discussions. Does that make sense? Okay, awesome. Any other questions before we wrap up? All right, well, thank you again, everyone.